What about probability with permutations and combinations? And I said before we begin this, let's think about probability. Remember that probability, we can determine probability by the number of successes. We'll run out of room. Successes over the number of possible outcomes. And it's this number of possible outcomes that we may be needing to determine whether we're dealing with a permutation or a combination. And then, therefore, what leads us to probability with permutations and combinations. So let's get specific here. We got 4 of the 12 members of the student council are being selected to hand out flyers at the mall. So we got a total number of objects of 12. We're going to be selecting 4. We got to determine whether the order is important for the number of possible outcomes. And it says, what is the probability? That's what cues us into this right here, that Hasina, Amy, Bonnie, and Tim are all selected. Well, let's think first about what's our number of successes. When we're talking about all 4 of these being selected, and there's really only one success of that. Now, what about the total number of possible outcomes? We got 4 members going to be selected out of 12. Well, does it really matter the order in which they are selected? No, it doesn't matter what order they're selected. It doesn't matter which one's first. It's not like they're occupying a seat in a seating chart. Their order would be important. And so we're dealing with a combination. And so we got 1 over 12 C4. Now, I'm not going to go through the calculation of 12C4 on the calculator. I've done it several times here in some of the recent videos. You can do it on our calculator. But the number of combinations of selecting 4 out of 12 when order is not important is 495. So our probability is 1 out of 495. In other words, there's a 1 in a 495 chances probability that Hasina, Amy, Bonnie, and Tim would be the 4 students selected to hand out flyers at the mall.